All right, guys, so the next page is page 334 through 340. They're a little more difficult than those first several pages. So it starts out talking about net force. So remember net force, if the forces are going in the same direction, you add, and if they're going in opposite directions, you're going to have to subtract. And so number one is talking about a balloon. And so, you'll see that. So the balloon says there's 2 newtons of net force up and 5 down. And then from right to left, you've got 3 newtons each to the right and to the left. So those 3 newtons on either side are going to cancel each other out. So it's going to ask you basically which way the balloon is moving. So again, opposites, you're going to subtract. And the other two are going to cancel each other out. All right, so number 2, keep in mind that the rock does not move. So I circled that on number 2. The rock does not move. And it wants to know which of the following statements have to be false. Well, the first thing you need to remember is the 2-pound rock has a force pulling downward because of gravity. So make sure you take that into account. So the rock itself has a force downward because of gravity. Number 3 is talking about an anvil. And I know some of you may not know what an anvil is, but an anvil is basically this big steel. I tried to draw a picture of it. This big steel is very heavy. It's used by blacksmith. If any of y'all ever watched Forged in Fire or anything like that, it's used to basically shape and hammer out metal. So, and they're telling you that it's hanging from a string, which I don't know how in the world you get an anvil to hang from a string, but we'll go with it because that's what the question says. So basically gravity is pulling down on the anvil, and the string obviously is going to be pulling up in the opposite direction. And it asks you what has to be happening for it to be motionless, for it to not move. Okay, next page, page 335, is asking you about that an object is moving at a constant velocity. So remember, your definition of velocity is speed and direction. So you're going to have to keep that in mind. You're looking at speed and direction if you're looking at velocity. Number 5 is talking about sound, and it asks you what the louder sound is going to look like. So here's a picture of a quiet sound here, and I want you to notice that the distance between the waves is pretty short. Now, a loud sound, your crests and your troughs are going to be much higher, but also the distance between them is much further. And the distance, remember, between crest to crest or trough to trough is called your amplitude. So your amplitude is the distance between the crest, and that should help you with that question. All right, number 6, a sports car goes from 0 to 28.8 meters per second in 6.2 seconds, and it wants to know what's the average acceleration. Well, to find acceleration, you're going to have to divide the change in velocity by the time that it took for that change to happen. So your change in velocity, you're going to have to subtract to find your change in velocity, basically 0 to this point right here. So your change in velocity is just this right here, meters per second. And then you're going to divide that by how many seconds it took for that velocity to change. On the bottom, again, it's talking about net force. Remember, your net forces, if it's the same direction, you're going to add. And if those forces are in opposite directions, you're going to subtract. Same thing in number 8. So number 8's asking you, it's talking about a swimmer and they're going to dive into the pool. What's going to happen to the diver? So they're telling you that the swimmer is going to dive downward, 585 newtons, and then the water is pushing up with 615 newtons. So those forces are opposite in direction. So you're going to have to find the net force and then tell me what's going to happen to the swimmer because of that net force. Number 9, it tells you that the weight of 9.8 million newtons is what the rocket is traveling, and it asks you what exactly half of the force is. So you're finding exactly half. So that shouldn't be too difficult. Number 10 is talking about potential and kinetic energy. So it wants to know the kinetic energy when something is at its highest point. So remember a roller coaster that we used to draw, right? Okay, so here's your highest point, and it wants to know how much kinetic energy that you have at that highest point. All right, page 337 is talking about a pendulum, and it's swinging back and forth. So we have this in our notes, and I'll post pictures of your notes in just a minute after I get through with this video. But your pendulum should look like this. So it's just like if you're swinging in a swing set. So remember that here and here, you're stopped for just a split second, and then you're going to get fast, and this is going to be fast, and then you're going to stop and go back up. And I'll post a picture of your notes from your spiral in that in just a second. Number 12, all you're doing is multiplying by 2. So it wants to know how fast it's going to fall in 2 seconds, and it's giving you the speed at 1 second. So all you're going to have to do is multiply 9.8 times 2. All right, next page. Remember when I was, we were talking about forces, and I would throw the glue bottles up in the air or drop them. So remember that gravitational force is dependent upon 2 things. One is the mass of the object. So remember, the more mass an object has, the more gravitational pull it's going to have. And then remember, the height of the object also changes its gravitational force. So remember, I don't have a glue bottle. I got the fish food here. So remember, if I hold it really, really high and drop it, it has more force than if I don't hold it very high and drop it. So gravitational force depends on, number 1, mass, and number 2, the height, which that height is just the distance between 2 objects. So the distance between 2 objects and the mass. Number 14 may get a little bit confusing, and what I had to do is I had to draw a diagram on number 14 because it's talking about 3 different objects. Those 3 different objects are basically in space. They have 3 different masses, and they're all different distances from one another. So I drew, let me see if I can hold it up and you can see it. I drew a little diagram. Let me get that into focus. So it says that A weighs 4 kilograms, B weighs 3 kilograms, and C weighs 6 kilograms. So obviously I drew C larger because it has more mass. Now, because C has more mass, it's also going to have more of a gravitational pull. And then it tells you that object A and B are 4 meters apart, object B and C are 3 meters apart, and object A is only 2 meters from object C. So they have a less distance, A and C, so their gravitational force is going to be more. So you're looking for things that are going to increase the mass and the distance for gravitational forces on number 14. Number 15 should be relatively simple for you. You're just finding speed, which is your distance over time. All right, page 339 is basically setting up a proportion. My phone is always telling me I have a low battery. You're setting up a proportion for if something traveled 200 meters in 5 seconds, how many meters is it going to travel in 1 second? You've been doing that since about 5th grade, maybe 6. You can set up a proportion. I know Miss Humphreys taught you well. All right, number 17, you're looking at a motion graph, and you just have time and then the height or the distance that the ball is rolling, and it wants to know when it stops. So remember, when you're looking at a graph, what does that line look like when it's at rest is what you're looking for. So if it's stopped, it's at rest. So where in that graph are they showing you something is at rest? All right, 340, last one. So you're looking at a graph again, car changing speed over time, and it wants to know at what time does the car's driving remain constant. So remember that if something is constant, that it is proportional through each second. So I drew this on mine to help me out a little bit. All right. And then last one, a soccer player kicks a ball, the ball rolls straight, slows down and stops, and what can you conclude about the soccer ball? So think about what was happening with the net forces. If something's going straight and then it slows down and then it stops, something has to be acting on it in order for it to slow down and stop. So think about the forces that would have to be acting on that ball from the time that they kicked it to the time that it stopped. All right, that is it for this week, guys. Please make sure that you're asking questions, reaching out to Remind if you need to. You can type a really quick question on Remind. I'm going to get back to you almost immediately. Remind is way simpler than what the stuff that y'all do on Snapchat and Instagram sometimes, so I know you shouldn't be having a problem with it. It's just like sending a text. Do not be afraid to ask me a question. That's what I'm here for. I do not want you to get in a confrontation with your parents. Some of your parents, they can't help you. They're working hard. And that's what I'm here for, guys. So don't be afraid to ask me a question. I don't mind. Whatever time it is. If you're having to work on your stuff after your parents get home and my Remind says after hours, I don't care. I don't want to answer your question 2 or 3 in the morning. But lately I've been up, though, because I can't sleep without going to school. Anyway, miss you guys.